All right, this is lesson 8.2b, Inequalities. So you'll need to have your notes out. Go ahead and write down this label. (8.2b) Inequalities. Now I want you to think about what that word means. And if you notice, if you look at it, it has that word equal right there in the middle of it. And so think about what that word inequalities might mean. And so maybe you can think of other words that have that same prefix, in. Maybe you guys can brainstorm for a second and give some ideas of what are some words that have in as a prefix there. So maybe indirect means that it's not the direct route. You guys come up with some others where that prefix means that it is not. So these would be things where it's not equal to. Well, or potentially maybe not just equal to. Maybe you have a group of things that some you could have it equal to, or maybe you could have things that are more than that. And so there's 4 inequalities that we're going to focus on. And 2 of them I know you've heard of, and then 2 of them are probably new. So let's get down a definition of an inequality. So you can write this in your notes. It's a mathematical sentence that compares quantities and quantities just means amounts using, and then here are our 4 symbols. We have a less than symbol, greater than symbol, and then here are the 2 new ones. So why don't you copy those down. And so, okay, so we said this one is less than, so let's write down its name. And I believe we've talked about that the less than symbol looks a lot like an L, and so therefore it's the less than. And then the other one would be greater than. But sometimes we might have a group of numbers, or maybe you're like, if you think about, you go to Chick-fil-A and you see the playland there, and it says that you have the cow holding its hand up, and he's saying, okay, you may come in and play if you are this height, or maybe if you're below that height. So you can equal the height, but you could also be less than the height because they only want little ones to come in and play. Well, that's this symbol, less than or equal to. So it's a combination of a less than sign and an equal sign. So that's called less than or equal to. So it's when you want a group that can be either of those categories. It's not saying that it can fall into both, because you can't be both less than and equal to. It's a less than or equal to. Now the other symbol then, you've probably guessed, is greater than or equal to. And I know a lot of you've been to Disney, and maybe there's a ride that's only for older kids, and so you go up and you have to meet this height, so you can equal that height, or you can be greater than that height. And that's what that symbol would be for. It's saying you want all the people who are this height, there's the equal or more than that height. And so what I'd like us to do is to come up with some different phrases that would mean these different symbols. And we'll talk about this more tomorrow as well. But let's just begin, and then we'll review it again in our next class. So let's list out our symbols and come up with different phrases. So here's our less than, greater than, like just other ways that we might, the way we talk in English, the way that it might actually mean these different symbols. So less than. Maybe we can pause the video even here and you guys could brainstorm a few ideas and maybe even come up to the board and write down some words that could mean these. And what I'm talking about is things like, you could say instead of less than, you could say fewer than. Instead of greater than, you could say more than. Those are the kinds of things I'm thinking of. So I think it'd be a good idea to pause it and you guys talk about some other words and phrases that might mean these. All right, so here are some that I'd like you to add to your list if you guys didn't come up with them. Would be instead of less than or equal to, that means that you can be, like if we're talking about height, you can be that height or you can be less than. So that's the most, that number would be the most you could be. So that would be at most is another way to say that. And then if you are waiting in line to ride at Disney, you can be this height or higher, so greater than or equal to. Another way to say that would be you have to be this particular, at least this particular height. So that's another phrase, at least. So those are just a couple, and you might have come up with some other ones. An example would be to say, okay, let's put a few examples of things that would be fewer. So you could say 2 is fewer than 5. 2 is fewer or 2 is less than 5. You could say for more than or greater than, 10 is greater than 6. 10 is more than 6. We could say that 7 is less than or equal to 20. Now, is that true? Is 7 less than or equal to 20? Yes, it's the less than part. It's not equal to 20, but it's less than 20. Now, would this be true? 20 is less than or equal to 20. Yes, 20 is equal to, so it fits in one of those two categories. It doesn't have to fit both, one or the other. Now, would this be true? 21 is less than or equal to 20. No, it's not, because 21 is more than 20. So that one would be, let's put a slash through that. That's not true. And then for at least, let's come up with an example. You could say maybe 14 is greater than or equal to 10. That's true, because 14 is the greater than part. And then would this be true? Is 10 greater than or equal to 10? Yes, it's equal to 10, so it works. But what about 3? Is 3 greater than or equal to 10? No, it's less than, so that one is not a true statement. So that just gives you a kind of an overview of how these inequalities work. Now, I want to show you kind of how some of your problems are going to be phrased in your homework and practice just to see, do you really understand what these inequalities mean? So here's what your directions might say. Let me clear this. So here it's say determine which number is the solution, and or I think I'll change it to is a solution of each inequality. So they will give you an inequality statement. It's going to have a variable in it. So let's try n minus 3 is greater than 6. And they're going to give you some values for n. And I want you to see if 8, 9, or 10 make that inequality true. If it makes it true, then it's a solution. So let's try 8. If we put in 8 minus 3, let's see what we get. 8 minus 3 is 5. Is 5 greater than 6? No. So 8 is not a solution. Let's try 9. 9 minus 3. So again, I'm plugging it in up here, plugging in these values. 9 minus 3, is it greater than 6? Well, is 6 greater than 6? No, it's equal to 6. It's not greater than. So 9 doesn't work. So let's check 10. 10 minus 3, let's see if that's greater than 6. Well, 10 minus 3 is 7. Is 7 greater than 6? Yes, that's true. So 10 is a solution to this inequality. Now, and actually, you know what? Let's say we want to try 11. Let's see if it has another solution. 11 minus 3 greater than 6. 11 minus 3 is 8. Is 8 greater than 6? Yes. So 11 would also be a solution. So I want you to think about how many solutions does this inequality have? Well, we know 10 works and 11 works. Do you think there would be other numbers that would make that work? Yeah, there's actually an infinite amount. As long as you go up higher than your 10, if you're dealing with whole numbers, then yes, it's going to be bigger, and so you'd have lots of them that could work. So I do want you to check each of your answers because maybe there'd be more than one. Okay, let's do these same directions and try another one, number 2. We'll do m plus 9 is greater than 13. And we want to see which of these numbers, I'll write some numbers down, will make that inequality true. So we'll do 3, 5, 7. We'll just do those 3. We'll do those. Okay, so let's say we put in, for m, let's put in a 3. So 3 plus 9, we want to see if it's greater than 13. Well, 3 plus 9, that's 12. Is 12 greater than 13? No. So 3 doesn't work. Let's try it with 5. 5 plus 9, 5 plus 9 is 14. Is 14 greater than 13? Yes. So that means 5 was the solution. Now we'll do a 7. 7 plus 9, is that greater than 13? Yes, 16 is greater than 13. So there were 2 that worked. Now, are there more than 2? Absolutely. There's a whole bunch. Okay, I'll have you practice that some more in a minute. Now let's do a little bit different type of problem. Here are the directions. Is the given value a solution of the inequality? So this is a similar type problem, it's just we're coming at it in a little bit different way. So I'll just call this part A. So we have x plus 7 is greater than 15, and let's say x is equal to 9. So we go back to the question. It says, is the given value, that's our x equal to 9, a solution to this inequality? So does that 9 make this inequality true? It's a yes or no, but I want you to prove it with some work. Don't just put yes or no. So we plug in our 9 for x. 9 plus 7, we want to see if it's greater than 15. 9 plus 7 is 16. Is 16 greater than 15? Yes. So that tells us that 9 is a solution to that inequality. Okay, let's try another one. 22 is Now, what's that symbol called again? Has our less than. It has part of an equal sign, less than or equal to 15 plus W, and W is equal to 6. So for this given value, we want to see if it makes this inequality true or false. And if it's true, then it's a solution. So 22 is less than or equal to 15 plus, we put 6 in for W. 15 plus 6 is 21. Is 22, when we read it from left to right, is 22 less than or equal to 21? No, it's greater than. So we would say no, 6 is not a solution to this inequality. It doesn't make it true. Let's do one more. 18 is greater than or equal to, there's that new symbol, 21 minus x. And x is equal to 3. So we plug it in, and we say 18 is greater than or equal to 21 minus 3. Well, what's 21 minus 3? 18. Is 18 greater than or equal to 18? Yes, it's the or equal to, so yes, that tells us that 3 is a solution. All right, the last part I wanted to show you, let me clear that, is in your books. So probably should pause the video for a minute, and I want you to get your books out and open to page 447. And I'll give you a minute there to get those out. You can open your textbooks. We're going to be looking at the bottom of page 447, letter D, about balloons. And this problem really has to do with the situation right above, so we should really read through this problem before we try to answer part D. And it says balloons. Louisa works for a gift and flower shop. She receives a bonus if she makes more than 20 balloon bouquets in a month. Which month did Louisa receive a bonus check? And that's that first question. Use the inequality. B is greater than 20, so B represents the number of balloon bouquets made each month. And so she receives a bonus. Let's see what it said. If she makes more than 20 balloon bouquets in a month. So there's that B is greater than 20. So we'd look at our table. It gives us how many she sold each month. Well, if we look at July, did she sell more than 20 in July? Yes. 25 is more than 20. What about August? Did she sell more than 20? No, she only sold 12. So she's not going to get a bonus there. September, is that more than 20? No, it's only 18. And October is 32. Yes, that's more than 20. So you can see there it says she got a bonus check in July and October. All right, so let's come down to the part D where it says check your progress. Suppose Louisa receives a free half day off work if she makes more than 35 bouquets in a month. Use the inequality. So the B is greater than 35. So we want all the values that are greater than 35, and those are the months when she will receive a free half day off. So let's look at July. July, she sold 25. So is 25 greater than 35? No. So she doesn't get that half day off. What about in August? Let's see, she had 12. Is 12 greater than 35? Nope, doesn't get it then. How about September? September she had 18. Is 18 greater than 35? Nope, but in October she's earned her free day off, free half day. Well, actually, nope, it's only 32. Is 32 greater than 35? No. So, does she get a free half day off? No. She didn't do more than 35. So she'd have to have at least sold 36 for her to be able to get it, and she didn't. So it didn't work out for her. All right, I do want you to practice a few here together, and we're going to go back to these same types of directions here that we were doing earlier. So I'm going to erase this, and I'm going to give some problems for you to try. And so what we'll do is I'll have them up here. You guys can pause the video, and then when everybody's finished, you can unpause it and check your answers and see if you're correct. So let me get rid of this. Oh, whoops. Back it up there. Oh, man. Okay. Let's try again. Okay. Just trying to avoid having to rewrite the directions again. Let me just say I hope that I will get a really good report back after being gone, that you have behaved really well and were super polite like I know you will be. Okay, so determine which number is a solution of each inequality. And I can't remember what number we were on. So we will just, I think we'll just start with, we'll call this number 5. So 32 plus A is greater than 44. And you'll need to check 11, 12, and 13. And then once you do 49 minus H is greater than or equal to 8. And let's do 40, 41, and 42. Okay, so you can do those two. And then we'll do this other type of problem. Is the given value a solution of the inequality? So this will be number 7. Let's do 12. P is less than or equal to 76. And P is equal to 6. And then number 8. Do K minus 22 is greater than 20, and K is equal to 38. So try those. Try them on your own, and get your answers, and then when everyone's done, you can start it back up, and I'll have the answers back up there for you. All right, so hopefully you've all finished, and let's come over here. We're going to check each of these. Let's first try 11. 32 plus 11, we want to see if it's greater than 44. If we add those, we get 43. Is 43 greater than 44? No, so 11 didn't work. All right, let's try 12. 32 plus 12, we want to see if it's greater than 44. So I add and I get 44. Is 44 greater than 44? No, it's equal to. So that didn't work. So let's check 13. 32 plus 13 is greater than 44. We get 45. Is 45 greater than 44? Yes, that one is true. So 13 is our solution. All right, let's try number 6. Let's plug each of these in. We'll start with 40. 49 minus 40 is greater than or equal to 8. So we get 9 is greater than or equal to 8. Is that true? Yes, that's true. So therefore, we put in 40. That means 40 is a solution. All right, let's try 41. 49 minus 41 is greater than or equal to 8. So we get 8 is greater than or equal to 8. That's true. It's in the equal to category. So 41 is also a solution. Let's check 42. 49 minus 42 is greater than or equal to 8. So we get 7 is greater than or equal to 8, which, is that true? No, 7 is less than 8. Whoops. So that's not true. We'll put false. So therefore 42 is not a solution. That one had 2. All right, let's check number 7. We'll put in our 6 for P. So 12 times 6. We want to see if it's greater than or equal to 76. Well, let's multiply. 12 times 6 is 72. And is 72 less than or equal to 76? Yes. So is it a solution? Yes, 6 is a solution to that inequality. All right, last one. We're going to put in 38 for K. 38 minus 22, we want to see if it's greater than 20. If we subtract here, we'll get 16. And is 16 greater than 20? No, 16 is less than 20. So that means that 38 is not a solution to the inequality. There are other numbers that are, but not that one. Well, that's basically the notes. So you now have some homework to do. You can work on it in class, and whatever you don't finish for homework, you'll need to finish it up tonight and then come to your next class ready for it to be graded.